Greetings, people of Earth. I'm Rick Harold. Thanks for watching my videos and listening to my podcasts. Today we're talking about a language I invented, a programming language, which was used in InstallShield. It's called InstallScript. InstallShield. Now, when we originally created it, I'd actually started looking around at languages at the time in terms of what we wanted to use. We had made the decision to use a procedural mechanism for the installer. So I looked around. We had a product called InstallShield, which was for creating demos, and you had a scripting mechanism in it. The scripting mechanism was a little bit more data-driven, not quite any file-based, if you guys are familiar with that. But it was similar to that. And looking through the installation process, it didn't seem very clear that we could do that and quantify enough of the data values. Microsoft also had an installer, which was any file-based, and one of the problems with it is it was just too convoluted and too difficult to quantify all the various states that an installation or updating process needed to do. So we chose to go with a procedural mechanism. I looked around. Now, this is 1990. There wasn't really there's no open source. I mean, there may have technically have been, but there was no open source languages. So I basically borrowed from C, because I felt that most of the people who would do any development would understand C. There were other languages like Pascal and Objective-C, which really didn't apply because we were on Windows. But because I was creating the language, I could really borrow from anything. Algol, PL1, and I had a lot of experience with lots of languages. Ada, which wasn't going to happen. The other part of it was I had to make sure that this was also simple. So C's not simple necessarily. Depends how you use it, right? C is powerful because you can do a lot of funny things in it, which are useful under certain circumstances. Pascal's a little bit more rigid. Ada's very rigid. So I chose to go with a C-like language, very procedural. And I'm not going to go through the whole history here. I'm sure some people would be interested in it, and I'd love to talk about it. But that was kind of the basis of it. So it started from a C mechanism. And one of the other things that we wanted to make sure about it was we didn't know a lot about installation in the sense that what everybody would need. And back in 1990 to 96, PCs were really changing rapidly. Windows was changing rapidly. I've talked in other videos about OS2, which is not super relevant to this. But so we needed to create the language so that it could be extensible without us having to get involved. And that was always kind of a big deal. We didn't want to create InstallShield as the bottleneck in terms of our customers getting work done. Because once you do that, it's just a never-ending cycle of support problems. And while you could argue, oh, well, there's support opportunity for sales, that's not how you end up helping the customer out. You need to empower them to do their own job and to help them and support them, not to constantly try to squeeze money out of them. And if we had done that, we would never have been able to handle the support process. As it was, because it's a technical product and a technical environment and leading edge, because these operating system releases come out often, and we have to be there ahead of the release for the beta, so our beta customers could use the beta OS with an existing installer. So we have to empower our customers. So I went through and I created a mechanism where it was a very dynamic language where you could extensively call directly into Windows. You could call into your own custom DLLs. There are a series of other mechanisms on there. And then, of course, we had to create a compiler. So we had to write a compiler. It was a interpretive language in a sense. We compiled it to P code, but then the P code would run it. Now, with anything like this, the next evolution in the process was we had to create a debugger, a visual debugger, because people had a lot of debugging issues. They would have constant things they say were not working. Once we provided the debugger where you could examine variables, just like with any regular language, they could see that, oh, my variable's wrong, or I did the program wrong, InstallScript wrong. Now, this all may sound, oh, of course, there's all these IDEs today, these design environments, and that didn't exist at all, right? It was crude city back then. Microsoft didn't even have a system. You had compilers. So we had to come out with the IDE and the visual debugger. Now, the debugger was separate from the IDE because of the nature of it, and it has to run potentially remotely. if you're trying to figure out a problem. So that was a lot of evolution, a lot of thinking during the process. We looked to Microsoft and Borland in terms of the IDE, in terms of borrowing ideas and structuring it, supporting still the same language. And even as the internet came out, one of the interesting things was, and again, to be honest, in 1995, 96, nobody really knew what the internet was going to do, other than it's super amazing and cool. And believe it or not, I had used ARPANET in college, and it saved me in one of my projects. But this idea of connectivity was new. So we had actually started working on some functions called internet functions, where in the script you could call a server with this internet function, and the server had code on it which would run, which to me, because I love Lambda functions and these serverless functionality that you can scale out and not have to support from a ops point of view, it was kind of like that, except there was you had to support it and you had to support the operation on the server. But we had the idea of using this small functionality. And the reason why is as installations would go out, you needed a dynamic language. You needed to have a mechanism to remotely change things on the fly, because once you burn millions of CDs or DVDs or floppies, really, companies would have these locked-in errors that they'd eventually figure out, oh my gosh, we have a bunch of customers with these problems. We have to be able to update it. So we kind of created a mechanism to do that. A lot of that didn't get implemented. There's many reasons for some of these things. Some of my other videos I talk about our internet strategy. And anything with a small startup company, small meaning up to 300 people, it's easy to get distracted if you don't try to maintain focus on things. So we didn't actually implement the Lambda function that back then, but it was something we started working on. It was something I thought would have been really useful. Now, our customers could do it themselves, and they did, right? So we didn't have an update solution at the time, and they used the script, and they were able to do extensions to do that. Third-party companies started creating extensions for our language that would help our customers, their customers also, do lots of things we could never anticipate. So it was pretty cool. Windows installation changed over time. It's a little bit more, it's more state-based now. In fact, it's probably almost all state-based. And believe me, I can get a whole big discussion on that and containers and Docker and all these cool things that are out there now that have really changed the landscape. But the language was really helpful. We always had to work on making it efficient. Now, of course, the question would be, let's say today, would we create a language or would we just borrow a language? And I can tell you right now, the big debate internally would be, yeah, you should use an open source language. Just pick one that's people like, I'll say Python, and create a structured API around it to do an installation language. You don't have to deal with creating your own compiler, blah, blah, blah. But this marketing talk, when you have a language and people are writing to your language, people get locked into the product, right? So you're writing all this code. It's all written in InstallScript. It's all written in Objective-C. And for the most part, you're locked into those platforms, and you can't really move it. That's old thinking. But back in 95, that was kind of more of the thinking that would go on. We didn't really have that as an initial thinking of why to create this language. But I can imagine marketing, and I don't mean to pick on marketing, developers do the same thing. Talking about lock-in, right? That's always a comment that you have in companies. How do you lock people in? Competitive barriers. So that would be the thinking. I personally would just rather use an existing language today. There's so many cool languages that have a lot of variety of needs. And today, a lot of the technology is so advanced in terms of compilation or just-in-time compiling. It'd be awesome, right? You don't have to deal with that. And then you could focus on what you're doing. So that's it. That's a little bit of the history of the language. Thanks for listening, and take it easy.